Hey guys, welcome back. Let's dive in. Today we're going to look at finding the slope of a line without using the graph. Can we do that? What would that look like? Let's see. Random fact. McDonald's once tested having bubblegum flavored broccoli to put in Happy Meals. Kids didn't go for it. That's a big surprise. All right. We're going to start today by looking at subtraction and the nature of subtraction. We've got a number line here. And I've got a couple questions for you. How far is it from -7 to 5? When we say how far, remember we're talking about a distance. From -7 right here to +5 is right here. And how far is that distance? Okay? Now we can count on the number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can see that's 12 units. Now, if we didn't have the number line in front of us, could we find that just from having these numbers? And what would we do? Initially, you guys might say, oh, we're going to add those because the 7 and the 5 make 12. But we're actually not going to add them in the way we write it up. We're actually going to start with -7. And we're going to, and then we have 5. What we're actually going to do is subtract them. And if you think about that, -7 minus 5, we've been doing that for a while. That's just bad guys and bad guys. We want to always be able to see that as an addition problem of two groups of bad guys coming together. And we get -12. Now you might say, Mr. Ray, we just said add, and you said no, but then you added them. Correct. It did turn out to be an addition, but that was because we started our problem with a set of negatives, a group of bad guys, and then a group of good guys. And so the way we combine them together to find that distance is written as subtraction, and because they're mixed groups, good guy, bad guy, it ends up becoming an addition because of that subtract value. Let me show you what I'm talking about. Let's look at example number 2. How far is it from -9 to -2? So again, if we started here, there's -9. And now we're staying with both numbers on the same side of 0. These are both negatives. How far is that distance? We can count. 1, 2, 3, 4, 5, 6, 7 units. We can see that distance is 7. And if we, again, look at these, we can see that the 9 and the 2, if we added, would become an 11, which is not true. It's only 7. So how did we get there? Again, it's going to be a subtraction. I'll take my two values. And remember, I'll subtract the two values. Notice that gives me a -. The negative of the 2 is not the subtraction symbol. We have to subtract the numbers, which may be a negative. And we know now that when we have a pair of negatives with subtraction like that, they'll cancel. And now it becomes subtracting with good guys, bad guys. Okay, -9 plus 2. -7. We subtract off those two good guys that fight and kill with bad guys, and there are more bad guys left over, -7. Okay? My point here is that hopefully we can see to find distance is actually subtraction. If you want to know how far apart two things are, or the distance between them, you have to use subtraction. That's how we find out how far something is. So from here to here, we use subtraction, and the subtraction will give us that distance. If we want to know from here to here how far that is, and we didn't have a number line, we can subtract, and it gives us that distance, okay? Now, you probably are wondering, what about these signs? The signs are there. All right, I had to jump out for a second to yell at yelling kids. Where were we? Signs. We notice the signs are different, and that is an issue in this context The signs basically give us a direction. So negative 12 means the way we subtracted with problem 1 gave us a direction that we were heading to the left. So that's a negative 12 units going from right to left. And the second one, the way we subtracted it, also just means the direction was heading right to left. But we aren't actually going to have to worry about that with today and how we're using this concept. All we need to remember is that if I want to know how far apart two things are, I can always subtract them. And if I watch my signs, the good guy, bad guy, skills we already know with integers, it's going to give us a distance. Let's do one more and see how that goes. If I want to know how far it is from negative 9 to positive 8, what's that distance? I can literally write out negative 9 to 8, and it's going to be a subtraction. And again, if I subtract those two, we should now be seeing that those can just be two groups of bad guys because I can always rewrite it as an addition. So that subtraction symbol just connects to the 8. I now can see this problem differently as two groups of bad guys. And the distance between them is negative 17. Okay? If I subtract them, it'll tell me my answer. If I do another one more example, negative 4 to negative 11. How far is that? I could just write it up. Negative 4 and negative 11, and I need to subtract those two, which, notice, gives me a double negative in the problem. We cancel that because pairs of negatives cancel, and we now see it's good guy, bad guy. They're going to fight and kill each other with a result of 7. So how far is it from negative 9 to 8? It's 17 units. We don't have to worry about the sign with distance. We just want to know how far. How far is it from negative 4 to negative 11? It is a distance of 7 units. As long as we always subtract, we'll always find that distance. Move it on. All right. Can we use that skill we just learned on the last page to calculate slope without counting on a graph? Let's try that. Here's our line A. We'll pick a couple of points on here. All right, I'm back from yelling at my yelling kids again. Let's see what the slope of this line is. Okay, count down, count over, and we can see that it's down 1 over 3 for a slope of negative 1/3. The question is, can we get to this answer, discover this slope, if there wasn't a graph in front of us? Let's try it. We've got 2 points. This point right here is at negative 3, 4. Okay, and let's review real quick. Remember, any point is x and then y. Don't forget that. It's always x value first. So if I was trying to figure out what that point is, I would count over to the negative 3, up to the 4, and that's where I get the coordinates of that point. Negative 3 for x, up 4 for the y. Okay? Now, let's get rid of those arrows before they get too confusing with our slope. Our other point, same exact thing. This one right here is at 0 for its x value, and then we just went up 3 for its y value. So can we, using this point and this point, get to the same slope that we already had to begin with? Let's try it. Move this guy over a little to have room. Now, the goal here, the idea, is first, let's see if we can get to this negative 1. All this negative 1 is the distance between the two y values of our points. Our y values are this guy and this guy. And you guys can look at them and go, yeah, 4 and 3 is obviously a distance of 1. The only issue there is the sign. So let's start. And I'm going to draw an arrow on top. The reason why I'm going to draw an arrow on the top, and that's important, is because remember with slope, the y value goes over the x value. But with a point, the x value is first, the y value is second. That's where I see kids trip up a lot when they're learning this concept. So notice and remember, if I draw an arrow on the top for the y values, it'll help me remember in a minute to put that answer on the top of my slope fraction. And I follow that up when I do the calculation to find the distance between my x values with an arrow on bottom, which helps me remember to put that value on the bottom of my slope fraction. And then I end up with the y on top, the x on bottom, and my slope is correct. Okay? So what we're going to do here is on top, we've got 4, and we've got 3, and we can find the distance between them with subtraction. Okay? On the bottom, to find the x values, over here on my graph, I want to find that distance, how far apart my x values are from each other. And I can do that by writing those up and subtracting those values. Okay? And if we do the math, what are we going to find? 4 minus 3 is 1. Negative 3 minus 0 is still negative 3. And now the question is, does my slope of my points when I do subtraction, does it match the slope on my graph? And of course, right now, some of you I know are asking, well, the negative is on a different part of the fraction. Does that matter? Are these two equivalent? And the answer is, yes, they are. You could put the fraction, or the negative sign, right in the middle of the fraction. It doesn't matter. Anywhere there's a single negative means a negative fraction. So all of those are equivalent, and it turns out our method works, okay? This is good. So it turns out you can find your slope without having to use the graph. You can just subtract your points. And don't worry, we're going to do it again right now because I know you could use some more practice. All right, let's do it again. Here's another line, and let's start by figuring out the slope on the graph, and then we'll go from there, and we'll try it with our points. I can see that I'm going up 3, which is positive, over 1, which is always positive. So if I read my graph, I see that I've got a slope of 3 over 1, or just 3. Now we want to do the same thing with a set of points. And you know what? I'll use a different set of points than the 2 we used for our slope. Number 1, because it gives us room and things won't get as muddled up. But number 2, so we can see that any set of points on a line are always going to produce the same slope. You don't have to use the exact same ones each time. This is a point at 1, 1 for the x and y value. This point up here is at an x value of 2 and a y value of 4. So the question is, can we use those 2 points and arrive at the slope we need? Okay, I'm going to start by writing them next to each other, just so you guys can kind of see what's going on. I've got that point, and I've got that point. Now remember my slope, if we look down here, is y value over x. So remember what we just talked about. I want to have a slope in a minute that's y value over x, which means my y values need to be on top. I'm going to draw a top arrow to remember those need to be the top of the slope fraction. X's need to be the bottom of the slope fraction. And the distance between those, I'm going to subtract. So 4 minus 1 is going to be the distance between them. So when I say 4 minus 1, I'm measuring this distance right here. There's my 4, there's my 1, that are the 2 y values of the 2 points. Now I'm going to get my x's on bottom, and that's going to be this distance right here, which is going to use the x value of 1 and the x value of 2, and we're going to subtract those, 2 minus 1 on the bottom. Now these all ended up as positives, which made this a really easy example. 4 minus 1, 3. 2 minus 1, 1. And there you go. 3 over 1 is 3. I did end up with the exact same slope either way. And all I did was subtract my y values on top, x is on bottom. And I want to show you one other thing with this problem. I'm using the exact same set of points again, just to show you something else. So far, I was subtracting left to right. What if I subtracted the other direction? What if I subtracted that way? 1 minus the 4. I just changed the direction, but the y values are still on top. X values will still be on bottom, and now I'm doing 1 minus 2. Well, 1 minus 4 equals negative 3. 1 minus 2 equals negative 1. And what happens when you have two negatives on a fraction? That's right, they cancel, which means we still end up at positive 3, and everything works out for our slope. Here's the really important piece here. The subtraction is how we find distance on that very first page. And sometimes there was a negative sign, and sometimes there wasn't. It doesn't matter for our application today of slope, as long as we always go the same direction. Okay, and that was not very good with that highlighting. As long as I go from the back point to the front point in the two of them, both for x and y, I'm going the same direction, my slope works out. Or if I go from the front point, the first y value to the second y value, and then first x value to the second x value, as long as I go the same direction for both, my slope works out. Okay? The signs on your slope will take care of themselves. You won't even have to worry about it as long as you always subtract the same direction. Either subtract both the x and y to the left, or subtract both the x and y to the right. And if you have a negative, it'll come out in the fraction. If you don't end up needing a negative, they'll both either not be there or they'll both cancel out. It'll work either way as long as you head the same direction for both. Okay? All right. All right. Let's you guys try to. Here's your examples, and we're not even going to worry about you figuring out slope on the graph because that's not actually what we're trying to do. I'll even tell you what it is. 1, 2, 3, 4, 5. I went down 5, and I went over 2. So that means the slope here is negative 5 over 2. The question is, can you do that from points? We'll call that graph A. Or, yeah, we'll call this second one graph B. So can you, and I'll give you some points on the first one. I'll have you do it for yourself on the second one. If you look at these 2 points, that's negative 2, 6. And the other point is at 0, 1. Can you get the same slope for A using your point values that I already got on the graph? And then on graph B, why don't you go ahead and select a couple of points off the graph? Okay? Any of these points will work. Anywhere it crosses the graph works. You can pick any of those 2 points, calculate your slope with those points, then calculate the slope on the graph, and see if they match. Okay, pause this, go. All right, you're back. Let's see how you did. If I want to get the slope from those points, I need to subtract my y values, and I need to subtract my x values. And that'll give me the 2 components of my slope. I draw my arrow for y on top to make sure that I keep that on top, and it's 6 minus 1. I'm going to go left to right. You might have gone the other direction. As long as you did it for both top and bottom, that same left, you're fine. And negative 2 minus 0. 6 minus 1, 5. Negative 2 minus 0 is negative 2. So let's check. negative 5 over 2, negative 5 over 2. Remember, the negative doesn't matter. It's a negative fraction. Yep, we're good to go. If that's what you did, you got it correct. Slope on B. Let's pick a couple of points. Now, you might have picked different than me. That's okay. I'll pick this guy, which is x value of negative 4, y value negative 3. And then I'll pick this guy here, which has got an x value of 0 and a y value of negative 2. And just to mix it up, I'll subtract these guys the other direction. As long as I go the same direction for both, it's okay. So on the top of my fraction, to keep y's on the top of the slope, I've got negative 2 minus negative 3. Okay, that's something for you guys to watch out for. If you're subtracting a negative value, you need to have a double negative there. Watch out for that. Okay, then those cancel out. On the bottom, I've got 0 minus that negative 4. Okay, notice again, minus a negative means a pair of negatives. Don't use that negative on the 4 as the subtraction symbol. The 4 has its own negative. Pair of negatives cancel, and what do we get? We get negative 2 plus 3, that's 1. And we get 0 plus 4 is 4. Well, I don't know if we did it right. We better check the slope on the graph to see. Up 1, over 4. Yep, looks like we did it. The slope on that line is 1/4. The slope from our points, also 1/4. Looks like we did it correctly if you got that. All right, that's going to wrap it up for today. And before we head to the homework, just in case anybody might still be a little bit unclear on the concepts, if we look at, I'm going to pull a lot of this out of the way real quick so it's not quite as confusing. If you look at problem A, to find this distance of negative 5, that's subtracting our y values. That means we're using the 6 and the 1, okay? That's all you're doing. You're subtracting the 6 and the 1 to get that 5. And there's where we did that. Now, the negative, remember, will take care of itself as long as you go the same direction when you subtract on these, okay? So don't worry about that piece. The distance is the 6 and the 1. And then to find the distance between the x values, I'm going to see how far it is from that negative 2 to that 0, and that's going to give me the distance of 2, and there that is. We're subtracting the distance of those x values. That's on the bottom of the slope fraction because we need to have y over x, or rise over run, whatever makes the most sense to you. And that's how we end up with the same slope either way. Doesn't matter if the negative's on top or bottom, we end up with the same thing both ways. All right. All right, one more thing. Let's talk a little bit more about special cases and what their slopes are. Okay, we've got a couple here. We've got a vertical line and a horizontal line. And let's talk about their slopes. How would we do that? I'll call this guy A. And I'll pick one here and here, those 2 points, and I've got 3 for the x value, 2 for the y. And this x value, or this x and y is 3 for the x, 0 for the y, because it doesn't go up or down on the y-axis at all. And if I try to calculate a slope from this guy based on my points, I'll end up, let's write these guys next to each other. I'll end up seeing this kind of strange thing happen. Y values on top, x on bottom, 2 minus 0, 3 minus 3, 2 minus 0 is 2, 3 minus 3 is 0. Huh, what's that mean? What happens when we have 0 on bottom? That's an important concept to think about. Division is, or fractions, excuse me, are actually division. So what we're asking ourselves is how much can I divide the bottom into the top? If I picked something like 6 over 3, simplifying that, is us asking how many times will 3 fit into 6? I can divide 3 into 6 twice, which means that becomes the whole number 2. 6 over 3 is just saying 2 whole groups of something, 2 whole units. So if we apply this idea down to the 0, how much 0 can fit into 2? How much nothing can you fit into the number 2? Well, it turns out you could fit an infinite number of 0 into anything, since you're not putting anything in. You can keep adding nothing forever. You will never fit anything. You won't ever run out of room. You can keep trying to divide 0 into 2 forever. It'll be infinity. What do we call infinity in math? Do you guys know what that's called? Call it undefined. I believe we've talked about this earlier this semester. Undefined. I shortcut it as UND, but technically it's undefined. So it turns out when you try to find slope of a vertical line like this, his slope is undefined. And we see that when you try to calculate if you have points, because you end up with 0 on bottom. And you can't have 0 on bottom in any kind of a fraction. Now, what about line number 2 over here? Pick a couple of points anywhere we want off of that. We'll call this one -2 for the x, happens to also be -2 for the y. This one's -1 for the x and -2 for the y. And we'll do the same thing we always do. I'll subtract my y values on top, my x values on bottom, and I get -2 and -2. And notice it's -2 minus -2. Don't forget, that creates a double negative there. Those cancel, and I get -2 plus 2 on top is 0. And on the bottom, we get -2 minus -1. Don't forget, it's a double negative. Those cancel. -2 plus 1 is -1. And what is it when we get 0 on top of a fraction? Well, same idea. We're dividing bottom into top and asking how much of a -1, how many groups of -1 fit into 0? Well, nothing fits into 0. So if 0 is on top of a fraction, we always end up with 0. So it turns out the slope of any horizontal line is always going to be 0. And you can just memorize these two. I would highly recommend that. Anytime you have a vertical line, it's got an undefined slope. Anytime you have a flat line, it's got a 0 slope, okay? The way I teach kids to remember that is you can think about a skier. If a skier were to come off the edge of the hill and go down a hill that steep, aka a cliff, he's just going to fall and die. He's going to become undefined because you can't ski down a cliff. You just fall and die. Whereas if a skier is on a flat slope like this, what's his speed? What kind of skiing is he doing? Well, 0, nothing. His speed and his skiing just turn out to be 0. He doesn't move anymore. He just stops moving. So if you drop off a cliff, you're going to become undefined. Okay, vertical lines are undefined. If you're on a flat slope, perfectly flat, you just end up going down to 0. You have no speed, no anything. Okay, those are the slopes on our two special cases. You don't even have to do the work if you just can memorize those two special cases. Then you just know their slopes. But if you do need to do the work, it's always going to show you by doing the calculation as well. Okay, your homework. Line A right here. Show me his slope on the graph, and then take 2 points from this line on the graph and show me by points. Match up the slope for those two. Second line, line B. What is his slope? Okay, so do A's slope, B's slope, and then C. I'm not even going to give you a line. I'm just going to give you a set of points. -3, 4, and 5, negative 2. So if we had a line going through those 2 points, what would his slope be? And then problem D exactly the same. So now we're getting away from a line. I'm just giving you points and having you calculate just from those points, okay? As if there was a line. So C and D are actually easier because you don't have to calculate it both ways. A, I want you to do it both ways, line and points. C and D, just from points. All right, peace out.